When you think about how a car is built, you probably picture a bunch of smaller metal parts getting welded together, right? But what if you could stamp the entire side of a car from one single piece of super strong steel? Well, Tesla just filed a patent that shows exactly how they plan to do it, and it completely flips a fundamental manufacturing process on its head. So let's dive in and see how this could totally rewrite the rules of the assembly line.
So that brings us to the big question. Why hasn't this been done before? I mean, for decades, making a massive, complex part like a car's door ring all in one shot has been the holy grail for automakers. But it's just been impossible. The reason? To get the kind of strength you need for safety without adding a ton of weight, you need to use a process called hot stamping. And that process has always had a very, very hard size limit.
All right, so let's get into the weeds on this. The hot stamping size limit. In car making, you're always fighting this battle between making a car strong and safe and making it light and efficient. The best weapon in that fight is hot stamping. You take steel, get it red hot, shape it, and then cool it down super fast to make it incredibly strong. But this method has always had an Achilles heel. You just couldn't make really big parts with it. Yeah, the old methods just couldn't cut it. A simple single press? Way too limited. It can't do all the complex cutting and punching you need for something like a door frame. So the industry came up with the transfer press, which basically links a bunch of different operations together. But that created a whole new headache. Because all the parts were physically connected, it put a hard cap on the size of the thing you could make. You literally could not make a part as big as the side of a car. So, if a bigger, more complicated machine isn't the answer, what is? This is where Tesla's idea is just so brilliantly counterintuitive. Instead of trying to build one single, gigantic, all-in-one machine, they did the exact opposite. They decided to physically pull the whole process apart. And here it is. This is the core concept, right from the patent diagram. What you're looking at is a sequence of 4 completely separate independent presses. The real genius here isn't the presses themselves, it's the space between them. It's that separation, with smart robots bridging the gap, that finally shatters the size barrier. It unlocks the ability to make these absolutely massive, complicated parts. You know, a great way to picture this is to think about old-school blacksmiths. A traditional press is like one blacksmith working at a single forge. They're limited by the size of their anvil, right? Tesla's method is like setting up an assembly line of 4 master blacksmiths. Each one is a specialist. One does the rough shape, the next does the edge, and so on, with a helper running the piece from one station to the next. This lets them work on something huge, like a giant shield, instead of just a sword. So let's follow the journey. We're going to walk through this 4-step process from a hot blank of steel to the final part. Let's see how this assembly line of robotic blacksmiths actually works. We'll follow a single sheet of glowing metal as it becomes a finished, super strong piece of a car. It all starts here at Station 1. A robot grabs this massive sheet of steel that's been heated until it's glowing. Engineers call this its austenitic state, which basically just means it's hot and easy to shape. The robot puts it in the first press, and bam, it gets stamped into its basic 3D shape. The main form is created. But there's no time to waste. It's immediately whisked away to Station 2. Now we're moving from the rough shape to the details. This press isn't just bending metal anymore, it's piercing and trimming. It's punching out the big openings where the windows and doors will eventually go and cleaning up all the edges while that metal is still soft. Okay, now we're at Station 3, and this is the heart of the whole operation. This is where things get really, really clever, because it's doing 2 critical things at once. It's doing some more detailed piecing, but at the same time, it's starting to quench, or rapidly cool, very specific parts of the component. We are definitely coming back to why that's so important in just a minute. And the journey ends at the last stop, Station 4. This is the grand finale. The entire part gets a rapid, full-body quench. This final super-fast cooling is what locks the steel's molecules into their strongest possible state. It completes the transformation from a simple hot sheet into a complex, high-strength structural powerhouse. All right, remember how I said Station 3 was the secret sauce? Let's zoom in on that, because this idea of selective temperature control is a huge deal. This is what lets engineers literally design different levels of strength into different areas of the very same piece of metal. Now, to get this, you only need to know 2 words. When the steel is hot and soft, it's austenitic. Think of it like workable clay. When you cool it down really fast, it becomes martensitic, which is incredibly hard and strong. Think almost diamond-like.
The entire game is about controlling that transformation from one to the other precisely where you want. So this is the magic trick happening back at Station 130. The press die is engineered to be a genius. It's simultaneously flash cooling the outer edges of the part, turning them into that super strong martensitic steel for structural integrity. But at the exact same time, it's keeping the center hot and soft, or austenitic, so it can easily punch more holes without cracking the metal. It's literally getting the best of both worlds in one elegant step.
So you're probably thinking, okay, that's some really cool engineering, but what does it all add up to? What's the so what? Well, it adds up to a massive leap in speed and efficiency. This isn't just some clever trick. It fundamentally rewrites the economics of building a car.
And here it is. This is the truly mind-blowing number from the patent. The entire four-step cycle we just walked through to take a flat sheet of steel and turn it into a finished, complex door ring with engineered strength takes just 3 to 10 seconds, not minutes, seconds. For anyone looking at this from an investment or a manufacturing perspective, that is an absolute game changer for production volume. So let's just put it all together. Let's recap the key advantages. You can now manufacture parts on the scale of a car's entire side frame, which was impossible before. You can complete one of these parts in as little as 3 seconds. You can create custom strength profiles inside a single component. And the whole system is flexible and modular. It essentially takes every single problem with the old way of doing things and solves it. And it all comes back to this one brilliant insight. For years, the auto industry saw the physical separation between presses as a limitation, a problem. Tesla's breakthrough was realizing that this separation is actually a massive advantage as long as you connect it all with smart robotics and precise control. It just makes you wonder what other so-called limitations in manufacturing are just waiting for a new perspective to become the next big advantage.